Okay, we're now going to do 3 perpendicular bisectors on a single triangle. And what's cool about this is they all meet at a single point, and that point is called the circumcenter. So I'm going to do this triangle right here, and we're doing 3 perpendicular bisectors. We already know how to do perpendicular bisectors. We've done this a couple times already. Once just perpendicular bisectors on a single segment. We just did it with mid segments if you've watched that video already. So compass more than half. Okay, we're going to draw the football. There's one arc. Going to the other end point. Drawing the second arc. And now we're going to connect. Now this time we're going to completely connect it. Remember, for mid segments we just made a little mark in the middle. So you're going to completely connect from here to here. And we can actually go a little bit farther because sometimes that is necessary. So draw all the way through this nice long perpendicular bisector. Notice that it should look perpendicular and it should look like it cut this segment in half. If it does not look that way, if it's obviously wrong, then you probably did something wrong. You need to start over and try again. Okay, so now let's go to a second side. So I got this side up here. I can shorten my compass up a little bit. Alright, so at the end point again, draw an arc. I'm going to go to the other end point and draw another arc. Okay, again I'm going to connect. It's my nephew in the background if you can hear him crying. Okay, we're going to connect completely, and once again, sometimes we go past, we're going to need to, because what we want to do is we want to see this perpendicular bisector intersect that perpendicular bisector. So obviously we're going to need to make this one a little bit longer on the top. So coming all the way through. Okay, that point right there should be our circumcenter. However, it's always a good thing to do the third side just in case we have a mistake somewhere. If we do have a mistake, then all 3 will not intersect at a single point, and they'll intersect more like a triangle than a single point. So we're going to do the third one just to make sure that what we're doing is correct. So compass more than half, that looks pretty good. So draw our arc. So where it gets confusing again sometimes because we've got lots of arcs going on now. Right, and down here. Okay, so lots of arcs going on. And we're still looking for this point of intersection here, obviously. If you follow it down, it's pretty easy to see it's out here. We're going to bring this in. We're going to connect from here to here. And we hope that if we did it correctly, all 3 points intersected a single point right there in the middle, which they do. That means we did this right. This point right here is called the circumcenter. There's a few important facts you need to know about the circumcenter. Okay, so obviously the first thing, it's where the 3 perpendicular bisectors meet. So that's what we drew. We drew the 3 perpendicular bisectors. It's called the circumcenter. If you think about the prefix circumference or circumnavigate. Circumference means the distance around a circle. Circumnavigate means to travel around the globe. So this idea of circum has the idea of traveling around something. What we're going to draw is we are going to draw what is called a circumscribed circle. Circumscribe means to draw around a shape. So we are going to draw the circumscribed circle. The circumcenter is the center of the circumscribed circle. Some books refer to this as the circumcircle, right? But circumscribed circle. Now, this next thing you need to know, if this point is the center of a circle that goes around this triangle, every vertex of the triangle has to be on that circle, which means that the distance from here to here is the radius of the circle. The distance from here to here is also going to be a radius, and the distance from here to here is going to be a radius. That means that this point is equidistant to the 3 vertices of the triangle. That's another fact you need to know. So, facts about a circumcenter. It's where the 3 perpendicular bisectors meet. It's the center of the circumscribed circle. It's the same distance to every vertex of the triangle. So let's go ahead and draw that. So what we're going to do, put our pivot point here. We got that a little bit too far, so let's narrow it down just a tiny bit. See if I got this right now. That looks pretty good there. Before, it's a little bit wide still. Before I draw it, I'm going to double check every single corner and make sure they all look correct. That one looks pretty good. And finally that one looks pretty good. So they all look pretty good. I'm going to take this, and sometimes it's easier to spin your paper than it is to actually draw the circle. So, spinning my paper, and I already have a little bit of a mistake. It looks a little bit wide on that edge. Let's narrow this down a little bit. That happens sometimes. Alright, so we're going to draw this circle. So we got that. We got them all matched up. Alright, so here we go. Draw this circle here. Alright, so it looks like I missed that one just by a tiny bit, but overall it looks pretty good. So we've got our circumscribed circle going around our triangle. This point is the same distance to every vertex. A couple other things you will notice if you do this on multiple triangles. This was an acute triangle. The circumcenter is obviously inside of an acute triangle. If you had an obtuse triangle, then the circumcenter would be outside the obtuse triangle, and where it would end up outside the obtuse triangle is it would actually end up outside past the longest side. I'll just draw you a really quick sketch of this and what that would look like. I'm not going to use my compass, but I'll just draw you real quick what it would look like. So let's say I've got an obtuse triangle, and if we do the perpendicular bisector for every single one of these, I'm going to ignore the compass work part, but that would go something like that. This would go here, and then this one would obviously go here. So our circumcenter would end up way outside, and our circumscribed circle would end up really big like that. Yeah, obviously that's a really, really rough drawing of it, but that's basically what would happen with an obtuse triangle. And if you draw an obtuse triangle, you can check that yourself. If you do a right triangle, this one's actually a little bit more interesting. Right triangle, right? You have your one perpendicular bisector. You have your second. Whoa, that's really bad. You have your second one right there, and then you have your third one. You completely ignore this. You have your third one here. And what happens is that the circumcenter ends up on the hypotenuse itself, smack dab in the middle. Right? It's the midpoint of the hypotenuse. And then once again, you could draw the big circle that comes around the outside, or something like this. Once again, obviously using a compass is going to make us a lot more accurate. Okay, so again, all the facts you need to know. Perpendicular bisectors, if you draw all three of them, they meet at a point called the circumcenter. Circumcenter is the same distance to every vertex. It is the center of the circumscribed circle, which is a circle drawn around the outside of the triangle, touching every vertex exactly once. The circumcenter is inside an acute triangle. It's outside an obtuse triangle, and it's at the midpoint of the hypotenuse for a right triangle. So those are the things you need to know for the perpendicular bisectors and for the circumcenter.